Hey, welcome everyone to this video. My name is Dario Macchi, and if you don't know me, I'm the developer advocate of Howdy. I'm here at the beautiful Howdy house of Montevideo, and we are here to talk about performance, specifically about Node.js performance. And to do that, we welcome Rafael Gonzaga. Hey, Rafael,
Hello.
how you doing?
I'm good, and you?
Great, great. Rafael will be giving a very interesting presentation about this topic. Rafael, thank you for being here and welcome.
Thank you. Yes, let's do that.
Okay, I will introduce you. Rafael Gonzaga is principal open source engineer at NodeSource, but also is part of Node.js Technical Steering Committee, right?
Correct, that's correct.
Okay. Just out of curiosity, what is the Node.js Technical Steering Committee and what do you do there?
The Technical Steering Committee is more, we define or we tend to define the future of Node.js. So any particular topic that might impact the development of Node.js in the future, and we don't have a consensus, we have discussions to find the better term for the features, for fixes, security. So I've been part of Node.js, working full time on it for the last 4 years, and we have been discussing different things over those years.
Okay, it sounds amazing. So today we will be talking about performance, benchmarks, and your experience around this topic, right?
Yes, that's correct. I have been working with performance for quite a long time, and I've been working with Node.js for also a long time, and I know exactly what's the problem people see when benchmarking their application, and I'm going to explain why most of their benchmarks are wrong.
Okay, great. I can't stop to hear you talking about that more. I will be interrupting you every now and then during the talk, just with comment or some questions that come up. But go ahead, the stage is yours.
Okay. So, as it was said, my name is Rafael Gonzaga, and I'm here to talk about why your Node.js benchmark is wrong. First of all, let's start with this statement: a benchmark is an art. So benchmarks is not simple as measuring before and after your change, and if the code is faster or if you have more operations per second, you are good. That's not right. There are many opportunities for mistakes and oversight, especially when you deal with interpreted language as a JavaScript. Where many optimizations can take place. The architecture is important. So let's start with some benchmarks methodologies. I'm going to explain some of them. One of them is correct. The other one, I suggest you to not do that, okay? The first one is called fire and forget. So it's very easy. You run the workload tool, let's say Apache benchmark, AutoCannon, JMeter, doesn't matter. You have an HTTP server, you run the workload too. Then you go to walk, have lunch. Then you get back to your machine and you rely on the benchmark result. This is not right, okay? This is when you leave your computer, especially when you run your benchmark in your local machine. There are many things that can happen that will affect the benchmark result, and you will be spreading the wrong message to your company, to the community, regardless of what you are measuring. One thing important to mention is Node.js is CPU sensitive, so no Node.js app should be measured when CPU is saturated. And the only way to measure if your CPU is saturated, if you stick at your computer and see the graph, see the CPU usage, okay? If you just go to walk or go have lunch and get back and just look to the results, that won't be enough. So CPU saturation will provide inaccurate results. Imagine that you are running your Node.js your Node.js server, and then you run the workload too, and you see that the CPU goes to the saturation mode, and the expectation on the when you measure locally, where your machine is sometimes bigger than the one that you use in production due to horizontal scalability, you see, okay, this app is doing 100,000 requests per second and I'm good. And then when you put that in production, you see that the result is not exactly what you expect. So this is because you are not measuring that on the correct machine, and you are not measuring CPU saturation on that. So don't do that.
So you're talking about that first stage of performance measurement that is done locally, and I think that is good advice that you are giving to us, because it's not, you can't fully trust in that kind of information. Besides, you are seeing the results, or you are watching your CPU. It's not the right place to test it, right?
Yes, that's correct. And I'm going to explain more about that later.
Okay, great.
Okay, let's go to the second methodology, which I called benchmarking. Basically, it's very simple. You run the workload too. If the result is not good, you check a different metric, let's say memory, let's say storage usage, and then you cherry pick the data if the second doesn't work, and then you share that. Of course, don't do that, okay? And the third one is the one that I suggest, is the active benchmark. You run the workload too, you analyze how your application is behaving with the observability tools. You can use Clinic.js Doctor, you can use Node Source for that, there's AnySolid for that, Flame Run, many tools that you can use to do that. The Clinic one is very simple, and I'm saying that because I maintain Clinic, or I am used to maintain Clinic.js. So you run Clinic Doctor, run your server, then in another terminal you run your benchmark tool, and then you get this output: the CPU usage, event loop delay, the amount of active handles, memory usage over time, and then you see that it might have a potential I/O issue or a long event loop delay. You can analyze that while doing the benchmark. So, and there is a second methodology which is called use method. This was well spread by Brendan Gregg. And for every resource, the idea is very simple. For every resource, you check utilization, saturation, and errors. So for instance, you get one resource which is CPU. For CPU, you check utilization, you check saturation, which is the queue length in the CPU, and you check the errors, the number of error events. You can check that using different tools, eBPF, top, atop, and for memory you can use flags like tracegc, eBPF, different methodologies depending on the focus of your optimization, of your benchmark.
So utilization, saturation, and errors are something that you can watch beside the technology, right? So for example, if you want to optimize something that is not Node.js, there are things that you need to watch in other kind of languages, because I believe that they are generic enough.
This is a generic approach for benchmarking. Right. I say that because usually when you measure utilization, error, and saturation, that's regardless of your process. It doesn't matter if you are using PHP, Java, or Node.js. They are the same.
Great.
All right. Then you make sure that your benchmark has no collateral damage, and then you share it with source code and environment details. It's very important to share your benchmark with the benchmark code and the environment you run that, because some benchmarks might be very fast on macOS, but they might not be as fast as you think in Ubuntu or in Windows and other environments. Okay? So, okay. I gave a very first introduction, and let's start from scratch. My name is Rafael Gonzaga. I'm principal open source engineer at Node Source. I'm from Brazil. a member of the Node.js Technical Steering Committee, which is also, if you don't, also say, if you don't like Node.js for some reason, that's partially my fault. I'm also sharing the Node.js security team, and I'm also a Node.js releaser. So if any of Node.js release breaks you, possibly that was me. If you found security vulnerabilities or your security scanner states that this version is vulnerable, possibly that's me as well. Okay? I'm also Fastify and a CleanJS maintainer. This is my social media. I've been trying to do live streams on Twitch and YouTube, helping people to contribute to Node.js for the first time, so feel free to join me on that journey. Okay, so I have said that, the benchmark methodology, but exactly where do I start a benchmark process? The first step is preparing the environment. This is the golden rule, okay? Anything can affect your benchmark. If you are running your benchmark in your local computer, you are in a Zoom call, in a Google Meet call with your colleagues, your teammates, this will affect your benchmark. If you are listening music in Spotify or YouTube music, this will affect your benchmark. And sometimes, even if you shoot near your hardware, this will affect your benchmark. Wow. This is Brendan Gregg on a data center in 2007, and he was measuring the disk I/O operations. So he was measuring the on this graph, the higher, which means more slow disk I/O operations. So he went to the data center and literally shoot in the data center. And then when he got back, he saw that the disk I/O operations increased by a peak of almost, I don't know, this is just some numbers, but 500 milliseconds, okay? So anything can affect your benchmark. So in another analogy, imagine that you are a soccer coach. Which player would you recruit for a team? You have the player A, who kicked all the balls to the same wrong location, never scored the goal. And then you have the player B, who scored randomly, but eventually makes the goal. Which one would you choose?
I will choose the B.
So the answer for that is the player A, because it's very easy. You just need to teach A to kick to the left. Then you make all the goals. For B, it's randomly. So reduce the variability. Yeah, reduce the variability as much as you can. So you must use a dedicated machine to perform benchmarks, okay? Because your local machine with several background processes running, your Cloud Code, your Windsurf, any LLM tool you are running in background, this will affect your benchmark. They share the same CPU resource as your tool, as your app, okay? So this is another example. Isolating the benchmark in the JavaScript side. This is a test function that basically measures how many operations this function has executes in 1 million of operations. Let me rephrase. You send a function to the test, and then it will execute 1 million operations and return how long it took. Okay? So let's say that I want to measure if error function is faster than regular function. I'm passing the error function here, okay, inside the test, and then I'm passing regular function inside the test. The result for that was error function took 2 milliseconds to conclude, while regular functions took 5 milliseconds to conclude 1 million operations. Then you say, okay, I will bring and I will refactor my whole code to use error function. But if you just change the order and execute the regular function benchmark first and then error function, the result says that regular function is faster, error function is now slower. So how it works? Usually, when you are executing JavaScript benchmarks, those benchmarks must be running isolation in its V8 environment. So by the time that you execute the second benchmark, the QE or the optimizations of V8 were already executed. So when you run a second set of operations, a lot of de-optimizations happen that makes the regular or the second test function you are executing is lower. So this is not true. If you run just spawn two different processes that measure the same thing, error function and regular function, you will see that they behave equal. So those benchmarks, those JavaScript benchmarks must be run in isolation. That's why when you are seeing a micro benchmark on X, on Twitter, and you see that people are executing a set of benchmark and then another set of benchmark right after that in the same process, in the same V8 environment, that's likely wrong.
Okay. So basically, the context where you execute the test, it's also important.
Yes, totally. Because imagine that V8, it's smart enough to optimize your code. You are executing the same code 1 million times. So V8 will say, okay, this can be optimized away. So I will drop this code and just execute that based on the previous result. So that's very fast. And then imagine right after it ends, you execute 1 million operation, a different operation. So V8 will understand, oh, this code has changed. So I need to de-optimize that and optimize for this regular function. And this has a cost, which is changing from 2 milliseconds to 5.
Yeah, it makes sense.
Okay?
Now that you are saying in that way, it makes sense.
Evaluating results. So you need to be confident in your measurements. You should not just spread these benchmark results to the community, because this is irrelevant. Metrics are hard. It can be confusing, complicated, and most of the time plain wrong. Okay, so the benchmark workflow is you have a dedicated machine, you run the benchmark before the change, you run the benchmark after the change, and then you compare the results. That's the usual benchmark workflow. Imagine that I run that before the change and after the change. And then after the change, the time elapsed for my app from 12 seconds went to 8 seconds. And then I create the pull request. Oh, I have improved the path performance by 30%. But is it true? A single benchmark is enough. How many times you should run the benchmark to make sure that this is correct? Okay? Most of the time, this is not, a single benchmark is not enough. And let me, I'm going to explain in details why. Because if you run that different times, you see different benchmark results. For the first time, you got 4 seconds faster. In the second time you run that, it might be 1 second faster, or even it might be equal, or even it might be slower. So how many times should I run a benchmark? There are many papers on that topic. The rigorous benchmarking in reasonable time is a good paper on this topic. I'm going to share it later. But when in doubt, use 30, okay? And I'm going to explain that. You store the A before, let's call A results as before the change and B result as after the change, okay? Let's store the benchmark result before the change for 30 times here. This is the results. And then you store the B results after the change. And then when you see the numbers, you will see that sometimes A result is slower and sometimes B result is slower, and that's fine. So how do I know if my change really impacts the performance or not, or just caused by randomness or variability? So that's why there is a statistical method called student t-test. Is used to test the null hypothesis, and I'm sure this won't be boring, okay? Imagine you plot the following data here. This is the results. You plot in a graph. You will see that most of the time B is faster and A is slower, but there are overlaps here. You will see that sometimes A is faster than B and vice versa, okay? So when you use the mean, this is the mean, the dots are the mean. When you compare the mean of B and the mean of of A, you will see that, okay, B is faster, I'm going to use B. But mean will lie to you, can and will lie to you. Never use mean for those kind of measurements. The average doesn't make any sense for benchmarking, or when you have a huge set of data, which is the case when you run the benchmark 30 times and then 30 times after that. The student t-test is called t-test because we find the t-value on that. And this is the formula, and I don't expect you to learn that because there is module for it, okay? But the golden rule is if the t-value is large, it means your change is statistically significant or the performance improvement is true. If t-value is small, there is no significant difference or the performance is not valid. So your pull request doesn't make sense. Okay? So what's small, what's large? There is a p-value for that, and in science generally we use 0.5 for probability. So for when you have the degrees of freedom 30, you don't need to understand that very deep because you can just require a module to test. Okay? So when you require to test, basically you send the set A and B. You use the p-value 0.05, which is the in the science for 30 we use that. And if the p-value is after calculation, if the p-value is less than 0.05, your change makes sense. Otherwise, it doesn't make sense. Okay? There is confidence on that. So, and one thing important on a statistical test is statistical, right? It's a probabilistic model. So there is a high chance of your benchmark to be valid, but there is still chance that it doesn't make sense, okay? It's okay. And this is very important because the Node.js can use that. The whole Node.js benchmark suite is built on top of that. This is an example of a benchmark run from Node.js. So we have the binary after the change, and we have the binary before the change. And then we are measuring a sync module. And then this is the result. A sync for these parameters with count 1, we have 3 stars of confidence, which means there are 0.01 chances of this result to be false for this architecture. So we do have 10% of performance improvement on this. And then we also have degradation of 10% of performance on this situation for when count is 1000, okay? For those that doesn't have confidence, we normally don't care because there are many variability on this benchmark file or on this result that this result is irrelevant, so you should not trust on it. That's why we use the confidence. And the confidence is calculated using the t-test model, okay? And last but not least, be realistic in your benchmarks, okay? I maintain a repository called the Node.js benchmark operations. It's a collection of micro benchmarks of small operations on Node.js. So it stores results from all active lines. In the time I wrote that, Node.js 14 was a thing yet. So it's very useful to find regression between Node.js versions. So for instance, let's do an example here. We have 2 ways of parsing strings to number. The first one using parseInt, and the second one is just adding a plus sign on it, okay? On my repository, I saw that on Node.js 16, using plus sign was way faster than using parseInt, as you can see. We have many operations per second in comparison. Technically, it's indeed 4 times faster, but when you put that in an operation per second, the plus sign is faster, indeed faster, but it only, if you refactor your whole code to avoid parseInt and use plus sign, you have just 0.006 milliseconds of improvement for each call. So is that worth the change? Most of the time, the refactoring a long code by just this small operation improvement doesn't make sense. So don't take that with a grain of salt, okay? And so let's do a recapitulation here. So do not perform the passive benchmark, which is do not go having lunch while doing benchmark. Do not perform benchmarking, okay? This is very crucial. Always run your benchmarking with isolation. Do not compare single benchmark runs, and be realistic when evaluating benchmark results.
Don't be tempted into doing benchmarking, mentioning the T-student approach, because that is very tempting.
Yeah.
You show a lot of numbers, and if you do all those measurements over a local machine while you are watching Netflix, it won't work, right?
Yeah, that's totally correct. And for all that said, there is a module that I wrote called bench node. With bench node, the problem with Node.js benchmarks, we saw that when comparing the error function versus regular function, that there are that code elimination. V8 will optimize your code away. There are inconstant optimizations because when you change the order, the results change. And there are no statistical validation. So you need to install the t-test module yourself. You need to find the p-value. You need to do all this stuff. But I wrote this module to abstract all of that for you. It's very, very easy. So benchmark, the bench node is an V8 optimized control benchmark specifically for Node.js. You have two measure modes, so you can measure operations per second while measuring time mode. You can check the statistical significance, and this also run in worker thread isolation if you want. So the usage is pretty simple. You install bench node, you import the suite, you instantiate the suite, you create your benchmark case, and you run that. And this will avoid that code elimination because internally we have added flags to V8 to say do not optimize this code away. So this is very important. And we have some warnings. For instance, DCA is dead code elimination. So when the benchmark identifies that your code is running much faster because V8 just removed your code because V8 is smart enough to say your code is not doing anything relevant, so I will remove that piece of code because it won't change anything in your app, and then your code is faster, and you think, oh, I wrote a very fast code, but that's not true. And then we have a warning here. Okay. There are many ways you can run that API. You can use on operations mode, on timer mode, and that's it. That's it from my talk. Bench node is here, and one thing important is that bench node was never meant to be a module. I wrote that to be inside Node.js core, but after discussion, and I wrote that and I created that pull request while doing a talk in Colombia. And after some discussions with TSC members, we decide let's make it a module. Let's make a community using that so we can find all the bugs it might have. Once it's stabilized, we can migrate it to Node.js core. So bench node might be on Node.js core anytime soon.
Okay, so you are waiting to make it more stable.
Yes.
For that, you need more people using it and reporting any issue. So maybe if you are out there, try it, test it, and we will do our part. Great.
Yes, that's correct.
No, it's very, very interesting. So, and it's interesting how you propose something to be in the core and those kinds of conversations. If you can add it right now, or if you need to wait until that stabilization. I believe that there would be a lot of politics inside those kind of discussions, because it's not just approving a PR and adding that code. I believe that you are not vibe coding that module also. Yes,
and back at the time when I wrote this module, vibe coding was not a thing.
No. And right now, for those kind of code, you can't vibe code it.
Yeah, I mean we are discussing the AI adoption of Node.js, and this has been a long discussion. I guess you might have heard.
No.
And I'm trying to find the pull request where, okay, I found that. This is the pull request I wrote for Node.js. Can you see?
Okay. Yeah, we are seeing it.
I wrote that, and then I published this on when doing a talk in Colombia. And then we had a long discussion on the usage, because the problem with JavaScript benchmark is that most of the time, as this talk explains, this is wrong. Most of the time, the micro benchmark won't represent reality because V8 optimize your code in different ways, in different layers that this piece of code will run different on different architectures, on different contexts. If you run that very often, if you don't run that very often. So if you just take numbers and share that, this will be wrong. So I'm taking all the caution we can have and making it clarify that your even writing this benchmark, even using bench node, you should be careful with those results. You need to measure that in production as well, because JavaScript benchmark is very, very tricky. So it's not easy as comparing apples to bananas. It's not that easy. So the only reason that I decided to move that to a module is because we need to be sure about what we are sharing. We need to be confident on it. And then we had long discussions. And then I said, okay, I don't have much time to work on this because I'm sponsored to work on security, not only in performance. So I said, okay, I'll make it a module. Let make people to use that, and then we get back to the discussion later.
Great.
Okay.
You mentioned a couple of times the micro benchmarks, and both times I believe that you associated with negative stuff or apply some kind of negative connotation. But I believe that maybe what you wanted to say is that the tool is not is right. It's a good tool, but the interpretation of the data is what we are doing about.
Yes, because for instance, when you are running a benchmark, it means that for this piece of code, you are asking the runtime to run several times. And when you think that V8 is not an interpreter, it will understand your code and see, okay, you are executing that particular function too much, so I can optimize that. And while in production, this won't happen because there are many things happening at the same time. You won't be executing this particular function at very often. This changes the whole thing because the micro benchmark will say your code makes 1,000 operations per second, and in production you see that a different result because you don't execute that very often. This is completely expected, but you can't have that on a micro benchmark. So the suggestion is to profile or benchmark our application in production, and that's why also NSolid exists. We do that.
And that leads to my second question, that is, you talk about production and trying to do this kind of performance test in production. Mm-hmm. And to do that, you need to resemble a real workload, or ideally the most real stuff compared with production. And that used to be it's expensive or hard to reproduce because of the data. So what do you want to say about that?
This is very interesting. So this is I work at NodeSource, and we are experts on profiling, benchmarking, CPU, any observability tools you can use on Node.js. Okay, and I'm not saying advocating for any software. Okay, you can use different tools, open source if you want, but it's very weird in my opinion that let's say that you install an APM, any APM like Sentry, not Sentry, Datadog, you have New Relic, you have different ways to measure a code in production, right? Yeah. But in my experiments, all of them introduce 30% of overhead. So it's very weird for me that to measure performance, you need to reduce performance by 30%. It doesn't make sense. So, and even if you just include some console.time performance.now to measure your code yourself, this will introduce overhead. So the idea with kernel tracing observability tools is, and that's what we are doing at NSolid, which is you can profile your app in production using real data and measure the performance of your app realistic without compromising performance. The overhead we have is like close to 5%, which is
because if not, the profiling tool becomes part of the problem.
Yes,
that's
correct.
Something that you don't want to do.
Yes, because imagine that you want to see to profile your application while you're doing the benchmark. Your performance will go down, and you measure something that will be very slow. The CPU saturation will go high, and the results will be irrelevant, right? So it's more for debugging issues, not to fix performance bottlenecks. So you can use different tools out there. You can use kernel tracing tool like eBPF. You can use you can add tracing yourself. I know that libuv contains their own tracing. So there are many open source tools you can use as well. It's more complex because you need to understand them, but still you can do that. It's a very complicated topic, to be honest.
Yeah, and I believe that it will depend if you are a small startup and you don't have a lot of people working on enhancing the performance of something, compared with someone that has a whole department or dedicated people working on the performance issues. Maybe I believe that also change from one project to another, and maybe you can tell us about, I don't know, if you have any sanity checks in order to trust in your measurements, because I believe that if I'm coding for a startup, I will set a couple of sanity checks in order to trust in my measurements. Mm-hmm. And I believe that you should have more about that because you are dedicated, or you was dedicated to the performance of Node.js. So how do you set those kind of sanity checks?
What I usually, I almost never share solid numbers. I can only share if my code make your app faster or not. Because maybe I'm doing my measurements in a dedicated machine and I have investigated a 30% of performance improvement. But I normally don't share those 30%. I only say the app is faster. Because then I put that in production and then I measure the impact of that. So it might be faster than 30% or it might be slower than 30%. But I know that this is faster, okay? Regardless if it's 1% faster or 30%, I know this is faster. So performance is basically you are making several micro optimizations in order to make your app faster. It's unlikely that a single change will make your app to be blazing fast. Usually it's like you are cutting different edges and making it better.
As you said initially, it's an art. So
yes,
it's difficult to measure with numbers an art, and you can say, okay, this is better than this one, but you can't quantify that.
Yes.
Okay, it makes sense.
Is at least JavaScript, the results you have from benchmarks, it's non-determinist. If you run your benchmark today in this machine, on this architecture, and you run it again, a lot of things might have happened in the background that you don't know, and the results might not be the same. So it's very hard to be confident in your measurements.
Okay. Yes, it makes sense. Okay, and I have one more question, because I heard this a lot about performance, that it's like the performance optimization is like a luxury or something that you can solve just putting more hardware on it, adding more hardware. And what I have my own opinion about that, but what do you think about that kind of argument against being performant or trying to make some piece of code more performant?
Mm-hmm. As anything in computer science, every statement should be taken with a grain of salt. I don't expect, if you are creating your business now and you're focused to be on performance, that doesn't make sense. You need to focus on your product and That doesn't matter if your app is returning 200 milliseconds or 500 milliseconds. You just need to have a good product. The problem arises when you have a product evolving, you have clients, and your cloud bills start to increase and you don't care about that. You treat performance as a technical issue, and you are like postponing the problem, and you never solve that. And when you see your app is very, very big and the performance optimization will cost you a lot of days to do, and your cloud bills will start to increase. So performance should be as any test. You wrote a module, you write a test. You wrote a module, you write a benchmark file. Okay, that's very easy. If you start small with tests, I'm sure that you can avoid your app being a giant monolith, very slow, and someone will arise to your team and will say, oh, we can't optimize that. It's better to start from scratch, to rewrite that from scratch. That happened many times during
I have it there, yeah.
Yes.
I know what you're talking about.
And now that people are using more LLM code, you see that LLM doesn't write a very, very good code, optimized code. They write code because the trained model are usually what people write, right? So they don't write very good code. So you might have a very good product, but the money you get from your clients basically goes to the cloud bills. So
it becomes a financial priority in some moments.
Yes.
Start tackling those performance issues. It's not something that a luxury that we as a technical team want to fix or want to make it more elegant just because of the sake of the technical stuff.
And despite that, I wrote on, let me see if I can find that. I wrote on module, not a module, but I wrote on blog post on network performance. I'm going to share this tab. The average human reaction time is around 200 milliseconds. So, which means that if you are open on e-commerce and your app is taking too long to conclude, I might think on something different. I might go to the competitor's website and you lose that sale. This is scientifically proved. Okay, so usually when you return in 100 milliseconds, your clients will be happy because they click and go to the checkout, they pay, and that's good. When they perceive the machine working, or when your app returns in more than 1 second, likely they will have a context switch. They will think on something different. So if I'm using an e-commerce, it takes more than 1 second, I will say, okay, let me check the same product on this competitor website, and then you have that issue. If you take more than 10 seconds, I will close the tab and I will never get back to your e-commerce. So this was proved long time ago. Walmart discovered by improving their page load time by 1 second, increase the conversions in 2%. And 2% for Walmart is a lot. Okay.
It's so for sure.
So there are different studies on that front.
That's very, very interesting. Okay, well, I believe that we are coming to the end of this video, but not before thanking you, Rafael, for everything you share with us. At least for me, it was very enlightening, and I believe that it was the right mix between practical advices and technical stuff and mathematical, but not too complex stuff. So it was a great talk. I believe that our audience will appreciate that too. So thank you. And for those that are watching this video, don't forget to follow us, follow Howdy in Instagram, YouTube, TikTok, to discover more amazing videos like this one. So thank you, Rafael, again.
Bye-bye.
Bye-bye.